Right, hello, London Gophers. So I'm Amnon, spelt for small a. I've been told that I have to stay within this square here because that's where the camera goes. The problem is I need to point to the slides, which means I disappear from the camera, but I think you guys can still see me, I think. I'm not sure about that. So I won't repeat the joke from a year ago why I'm spelt for small a. You just have to bear with me. Um, and going to talk about my favorite feature in Go, because everyone has their favorite features, and people talk a lot about Go routines, they talk a lot about channels, but my favorite feature is the fact that when you compile it, you produce a single statically linked executable, um, which is something people don't talk enough about. So I'm going to rant a bit here. Now, I just apologize for all the bling and all the sort of garish colors and all the crazy fonts and so on. I'm a repressed graphic designer. So you just have to bear with me. So basically, you build a program, you compile it, and it produces, a single file. A big file, your hello world weighs in as 2 megabytes. And the reason is it's got everything inside it. It's got a garbage collection. It's got a runtime. It's got everything. And I'm going to just talk a bit about why this is awesome. I mean, this of course you can cross compile. You want to run on your Raspberry Pi. You just change your two environment variables, your goose, your gotch, and it spits out a executable which will run on an ARM. So that's all very cool. If anybody's played around with building tool chains, cross-compiling using GCC, and the enormous pain you have to go through, being able to just make that change with two environment variables is really nice. But why is this a big deal? Why am I going on about this? Because isn't this the way computers work? Isn't this the way computers always worked? You have source code, you compile it, you produce an executable, that's it. You copy that executable, it runs. And to sort of explain why it's awesome, you have to compare with other languages and what happens with some of the scripting and interpreted languages. So I'm going to actually, in this talk, I'm not actually going to talk at all about Go, even though this is a Go meetup. I'm going to talk about other languages. So here on the left side, there's a go.mod file, which we all use now in the days of modules to define our dependencies. And does anybody know what this file over here is? Any Pythonistas around? So I'm a sort of a bit of a Pythonista as well, although people, real Pythonistas, will disagree. So that's a requirements.txt file, which is one of the ways in Python you define your dependencies. And the two files look very similar. They both have the package names, they both have the versions, they both kind of use semver. But there's one really, really crucial, really fundamental difference. And has anybody got an idea what difference I'm looking for? Any offers? It's not a hashes, not the URL. Oh, it's not for what, it's the when. So the fundamental difference is this all gets resolved when you build. Now, in the Python world, and really with any interpreted language, this gets resolved every time you deploy your code to a system. Every time you install the code on a new machine, all the dependencies have to be downloaded, all the dependencies have to be resolved. And that's a very fundamental difference, because in Go, you basically deploy a file. You basically copy a file onto your server, onto your container, onto wherever you're going to run. Whereas in Python or any interpreted language, you're deploying a universe. You're deploying your interpreter. You're deploying an entire set of libraries and dependencies. And that means that if you're deploying more than one script, more than one program on a machine, as you tend to do, you don't tend to buy a new machine for every program you deploy, then you need to make sure that you're in trouble if your different scripts require different versions of the dependencies. And then the smart people in the Python world have created all kinds of solutions to get around this. And the most common one is a virtual env, which is basically a directory where you install your entire Python world, all your dependencies, all your libraries. And then by magic of changing environment variables, you get your execution. You get your execution to find the dependencies from its own, copy of the universe. And that also means, has a nasty side effect, that you can't just run a program. You have to activate your virtual env. You have to source a bash file which will set the right environment variables, so that the interpreter will find the right dependencies. Now, things actually get. Now, this is a diagram which I didn't make it, and it's not somebody taking a mic. It's actually a real diagram from an excellent website called Full Stack Python, and it's basically how do you deploy a simple web app onto a server. So this is what happens, and you'll have to, anybody who's seeing me on the video will have to excuse me about me disappearing, because your app is this little thing over here, which lives inside a virtual env with all its dependencies. And your web app itself isn't a standalone thing. It talks a protocol. It basically has an API, and you have to put it inside a WSGI container in order that it can talk HTTP. Now, then the other obvious thing is you have to have a separate web server, which is a thing on the top. You have to have your Apache or your Nginx, because the built-in web servers in the Python frameworks, in your Flask, in Django, they all have their web servers, but all the web servers are toys, which don't handle SSL termination, which don't handle concurrent requests. So they're not usable for anything apart from development. So you need to be not only an expert in your own code, but also in configuring web services, in web servers, in setting up a WSGI containers. And then you've got this thing over here, which is your task queues. So the task queues are really the Python world's answer to Go routines. So when you have a long-running service, a long-running operation which you need to fire off from an HTTP request, you just launch a Go routine. It's trivial. Now, in the Python world, they have these task queues. The most common one of them is Celery, which and I've just copied a little section of the frequently asked questions from the Celery website. And it's got all these amazing questions. Does Celery really consist of 50,000 lines of code? And the answer, no, not at all. It's only 30,000. And questions like, I'm having integrity area duplicate keys. Why? Or why aren't the worker isn't doing anything, just hanging? MySQL is throwing deadlock errors. What do I do? Task results aren't reliably returning. So, lots of, I've purged all the messages. There's still more messages left in the queue. So lots of really fun stuff. And what the great thing about Go routines are? The great thing about Go routines is you never need to know about this stuff. You never have to troubleshoot this stuff. So I'm going to try to go backwards. So now I've gone forward, gone the wrong direction. How do I go back? Not the laptop, right? How do I? Button below, right. So let's go back. So this is deploying a simple web app in Python. Now, I couldn't find a Go version of this diagram, so I had to draw my own with my very limited graphic skills. And, oops, sorry about that. Let's go back again. and this is the Go version. So because you don't, if I go back again, because there's, the detail is all in your single static executable. So if we go back to this diagram, you don't need Apache, you don't need Nginx, you don't need a real web server, because the net HTTP library is a real web server, which is industrial strength. You don't need a tasky framework because you've got Go routines. You don't need virtual enums because your executable is statically linked and contains all the dependencies. So it makes life enormously easier. So really, just to wrap up, when you build a Go app, all the dependencies are resolved in build time rather than deploy time. You just have one file which you need to copy to your target machine. Only one executable, one process you need to run. And finally, Go is fun to write, but it's even funner to deploy. Well, I don't know if fun is a word, but that's it. Thanks very much, guys.